Okay everyone, so welcome to lecture, and in this lecture guys I'm going to talk about evaluation matrices, a very first matrix for a classification problem. So as we all know, and we have seen a classification problem. So for a classification problem, very first matrix that we try to consider for an evaluation is a confusion matrices, and we have named it as a confusion matrix, but it's not that confusing. So I'm going to clarify that part in this particular lecture itself. So let's talk about a confusion matrix in a very first place, that how confusion matrix works and what confusion matrix actually looks like. So here, let's suppose if I'm going to draw a table. Okay. So here, let's suppose if I'm going to draw a table, and here, so we have basically these rows, and let's suppose over here I'm going to write actually positive, yeah. So let's suppose I'm labeling it as a 1. I'm talking about a binary class classification, and actually negative, I'm labeling it as a 0. So obviously in a binary class classification, so there will be two classes. I'm considering that two class as 1 and 0. So 1 will be a positive class, I'm labeling it as a 1, and negative class I'm labeling it as a 0. And then you will be able to get a prediction, right? So predicted positive 1, predicted negative 0, yeah. So this is the matrix, and this matrix is technically called as confusion matrices. It's not that confusing, by the way, and all the other parameter for a evaluation we try to calculate based on this matrices itself. So here, let's suppose I'm expecting a actual positive, and if I have received even as a prediction as a positive, I'm expecting what? I'm expecting basically a positive, and I have received a positive outcome from a model. So model has even done a prediction as a positive. So in that situation, it's called as true positive, true positive, and we label that as a TP, true positive. Let's suppose I'm expecting a negative value, right? The actual value was a negative value and prediction was basically a positive. So this is basically a wrong prediction we are talking about, right? So I was expecting a negative, and system has done a prediction about the positive one. So this is called as false positive, yeah. So we try to label that as a FP. Now, so let's suppose I'm expecting a positive, right? And model has given me a negative. So here, falsely, model has given me a negative value. So we try to label that as a false negative. So false negative. Now let's suppose I'm expecting a negative, and even system has predicted as a negative. So here I can label that as a true negative. So TN. Now, these are the parameter which we are going to use: a true positive, false negative, and true negative to evaluate a model. With the help of this confusion matrices, we will get to know that how my prediction is, or how accurate my prediction is at the end of the day. So here, just to do a calculation, so what I'm going to do, I'm going to take one kind of a data over here. So let me take a data set in this particular place, and inside this particular data set, let's suppose I have actual value, and I have a predicted value. So the actual value was 1 and prediction was 1. Let's suppose actual value was 0, prediction was 0. Actual value was 1, prediction was 0. Actual value was 0, prediction is also 0. Actual value is 1, prediction is 1. Actual value is 1, again prediction is 1. Actual value is 0, prediction is 1. Actual value is 1 and prediction is basically 0. actual value is 0 and prediction is 0, and actual value is 1 and prediction is also 1. So now this is the reading that I'm able to get. Now based on this, I have to do a calculation that how accurate my model is. So I have an actual value which is given to me. You can say that as a y, and prediction value, maybe I can try to label that as a y hat. That okay, fine, system has given me a prediction of this one, and I was expecting basically these values, right? These values. Now if we have to fill up these values based on the like a data that we are able to read out inside this confusion matrices, how we are going to fill up these values, how we will be able to find out that yes, how many values are true positive, how many values are false positive, how many values are true negative, how many values are basically false negative. And then only I will be able to identify that how accurate my model is. And I can say that okay, fine, this is the confusion matrices that I'm able to draw based on the data, based on the reading which I'm able to get from the model. So here, if I'll talk about basically a very first one, which is a true positive one, what true positive says that the data was actually positive and even I have received a positive. So I was expecting a positive and I have basically received a positive value. So here I was expecting a positive, I have received a positive value. Then here I have like a actual value was positive and I have received a positive value. Again here, so I had a positive value, I have received a positive value, and then over here, so I had a positive value and I have received basically a positive value. So as per this one, we have 4 total true positive reading. Now if I'll have to talk about a true negative means what? So true negative simply means that the actually it was negative and even I have received a prediction as a negative. So here I had, let me change my pen color. So I had basically a negative value which is 0, and yes, I have received a negative value. Then again I had a negative value, I have received a negative value, and here so I had a negative value and then I have received a negative value. So true negative reading is equals to 3, right? True negative value is equals to 3. Now we can try to find out a false negative. What is the meaning of false negative? So actually I was expecting 1 and I have received basically 0. That is basically a false negative. So how many false negative that I had? So I was expecting basically 1 and I have received 0. So I was expecting 1 and received 0. I was expecting 1 and received basically a 0. So total false negative that we have is equals to 2. And then we have a false positive, means I was expecting 0 and I have received 1. This kind of a situation. So false positive. So how many false positive do we have? So false positive means I was expecting basically negative, means I was expecting basically 0 and I have received basically 1. So in total I have 1 value from this particular table. Now these are the total number of values. Now if I'm going to fill up these values inside this particular table, I will be able to get my confusion matrices. So true positive I can fill up as a 4 over here as per this particular data. And true negative I can try to fill up as a 3 over here, false negative I can try to fill up as 2 over here, and false positive I can try to fill up 1 over here. Now this is going to create a confusion matrix. Confusion matrix for me. So this is the confusion matrix for this particular data. So now whenever we are going to solve a classification problem, so this is the very first matrix that we try to draw, and based on this particular matrix we try to estimate that how my model outcome looks like. Basically this is something called as confusion matrices, and everywhere in case of a classification problem, so whether it's a binary class classification, whether it's a multi-class classification, you will end up using this kind of a confusion matrices all the time. So if model is 100% accurate, then you won't be having any false negative value, or you won't be having any kind of a false positive value. So this false element will be 0 and 0. False positive and false negative both will be 0 if model is 100% accurate. If model is not 100% accurate, if model is not performing well on each kind of a data set that you are going to pass, in that case you will end up getting some sort of a false negative or maybe some sort of a false positive values over here. As simple as that. So with that, thank you so much everyone. Take care, and in the next section, so I'm going to talk about more evaluation parameter.